Question 15 is a question on NBS, which was a radical reaction you learned for the first exam. And to start any NBS question, what you first have to ask is, okay, so each of these carbons have hydrogens on them, and I want to pull off one of those hydrogens and leave behind a radical. Where would that radical be most stable? Now remember, radical stability follows the same trend as carbocation stability, meaning resonance is best. And then if you don't have resonance, having a tertiary radical or carbocation is better than having a secondary, is better than having a primary, and all of this is way, way better than having a radical or a charge directly on a double bond. So if I look at this structure and I say, okay, here are hydrogens, hydrogen, hydrogen, hydrogen. These four hydrogens all around here are on double bonds, which we said are the absolute worst spot you could pull off a proton from. So the only spot you have to consider are these hydrogens over here. So what NBS will do is it'll pull off one of those protons and leave behind a dot, a radical. And now radicals kind of follow the same rules as carbocations aside from stabilities and the fact that they can resonate as well. And this is why the question asks, what are the two major products of the shown reaction? Because you always have to remember, after you draw in that most stable radical, your next job is to consider, well, is it stable due to resonance? And if it is, what does that resonance structure look like? So I have the radical here, and then I also have the resonance structure where one electron moves down there, one electron moves from there, and then we end up with an electron over there. Now remember, radicals, because they're unpaired electrons, you always have fishhook arrows, which means for each electron that is moved, you have to have one arrow. The radical is worth 1, and double bonds, when you're moving them through resonance with the radical, are worth 2. So you should have 3 arrows altogether, 1 from the radical and 2 from the double bond. And if this was just a regular old negative charge, well, usually it's just the negative charge moves down and this moves over. You only need 2. But because we're moving the double bond in a radical reaction, you need 3 arrows total, because the double bond is worth 2 electrons. Anyway, I digress. So the resonance structure you could get is where the radical ends up on the end over here, and now you have a new double bond over there. Now, I could also resonate with the double bond on the right, but that would end up giving you this as well, because what it would look like, I forgot the double bond there. If I resonated with this double bond over here, I would end up getting this, but that structure right there is this structure, because all I have to do is take this and flip it over like that, like whoop, and now it's the same thing. So technically that's only one structure, and that's why there are only 2 major products. Now, this isn't the major product, this is the intermediate. The major product comes from the other half of the NBS reaction. The first step, you make a radical, and you put that radical wherever it will be most stable. The next step is, once you have that radical and you've considered all resonance possibilities, you stick a bromine on that carbon where the radical is. So you have a bromine radical connecting here, and so you end up having a bromine here, and that's one possible answer. And then if the radical didn't resonate and stayed in the middle, that's your other answer, where the bromine gets added there. So these are your 2 possible answers, and this one matches up with structure 1 on the answer key, and this one matches up with structure 4 on the answer key. So the answer was 1 and 4, choice C.